Section 7.2, Properties of Exponential Functions. By the end of today's lesson, students are going to be able to explore the properties of exponential functions and also the exponential functions that have the base of e. The general form for exponential functions is y equals a times b to the x minus h power plus k. So this is going to cause our exponential function to shift. So let's talk about all the different transformations. So again, if a is greater than 1, it's a vertical stretch just like normal. If a is greater than 0 but less than 1, it's a vertical compression. And if a is negative, that's going to cause it to be reflected across your x-axis. The x minus h as the exponent is going to move it to the left or to the right. And then k at the end is either going to move it up or it's going to move it down. And if it ever asks for the parent function, the parent function is just going to be y equals b to the x power, okay? So you're going to ignore the a out in front, you're going to ignore the minus h, and you're going to ignore the k that's at the end. So your asymptote is now y equals whatever k is. The domain still negative infinity to positive infinity. As long as a is positive, your range is going to be from k to infinity. But if a is negative, that's going to cause it to flip around and it'll be negative infinity to k. Let's look at our first example. Y equals 2 times 3 to the x minus 1 power plus 4. All right, the easiest way to do these problems is to take the exponent, which is x minus 1, and find out what value makes it equal negative 1, what value makes it equal 0, and what value makes it positive 1. And then you just solve these three so we can find out what we're going to plug in for x. So we add 1 to negative 1, and you get 0, okay? Add 1 to 0 and you get 1. Add 1 to 1 and you get 2. So these three values of x is what we are going to substitute into our equation to help us solve this, okay? So let's look at the first one. So we have y equals 2 times 3 to the 0 minus 1 power plus 4. Okay, 0 minus 1 is negative 1. The negative 1 makes it a fraction. 2 times 1/3 makes it 2/3. And then to add 4, you must multiply by 3 over 3. So that's going to give me 2/3 plus 12/3, which is going to simplify to 14/3. So the first point that you are going to graph is the point 0, because that's what we plugged in for x, and then 14/3. Now we are going to plug in our second x value. So the second x value we got was 1. And now let's go ahead and simplify. So 1 minus 1 is going to give me 0. 3 to the 0 power is 1. And you're left with 2 plus 4, which gives you 6. So the second point you're going to graph is 1, 6. Let's see if I can fit the last one underneath this. Okay, plug in your last value of x, 2 times 3 to the 2 minus 1 power plus 4. 2 minus 1 gives me 3 to the first. 3 to the first is 3. times 2 is 6, and 6 plus 4 is 10. So the last point you're going to graph is 2, 10. Now let's make our graph. So let's start by graphing 0 and 14/3. So that's going to be a little greater than 4, almost to 5, okay. And then 1, 6, and then 2, 10. All right, now we need to talk about where our asymptote is. So remember, our asymptote is y equals k. So in this case, our asymptote is y equals 4. So 1, 2, 3, 4. Draw a dashed line because your exponential graph cannot go through this. And the graph should look something like this. All right, let's talk about the domain. So domain, still negative infinity to positive infinity. The range is going to start at where the asymptote is, so it's 4 to infinity. The y-intercept, we found it's the point 0, 14/3. The end behavior, as x goes to negative infinity, f of x is getting closer to 4. As x goes to positive infinity, f of x is going towards infinity. The natural base exponential function has a base of the letter e. So we're going to first look at how we evaluate using e. So let's find e to the 8th power. Look on your calculator. If you're using a graphing calculator, it's on the left-hand side, and it's under the word log button. Under that button is the ln button, and in blue is e to the x. You're looking on your calculator for e to the x. So when we hit the button e to the x, we then type in 8 because we're trying to find e to the 8th, and that gives me 2,980 point, and let's round to 3 decimal places, so 958, because after the 7 was a 9. And that's all you do to evaluate e to any power. Just type it in your calculator. Now we're going to look at exponential models that are using compounded continuous interest. So the formula for continuous interest is a of t equals p times e to the rt power. So p stands for your principal. E is the button on the calculator that we were just talking about. R represents the rate. Remember, it's the rate as a decimal. And T represents time. And A of T, of course, represents the amount after T time. Suppose you won a contest in the 8th grade that deposited $2,500 in an account that pays 7% annual interest compounded continuously. How much will the account have after 5 years? So since it said these keywords right here, compounded continuously, we use A of T equals P times E to the RT power. So remember, P stands for your principal. So that's how much money you started with, which is $2,500. E, the button on the calculator, 7%. Remember, we have to change it to a decimal. So we move it 2 to the left, so it's e to the 0.07 power times 5. So then we just pick up our calculator, type all of that into our calculator, 2,500, and then the e to the x button, 0.07 times 5. And since this is talking about money, we write $3,500 and 67 cents because we have to round up. Okay, there should not be an equal sign there, so let me get rid of it. So the amount they had after 5 years was $3,547.67.